Hello students. In our previous lecture, we had already talked about center of mass. Center of mass is a point where the whole mass of the body is concentrated and all the forces act on that point. So as we had learned about the center of mass, now we are in the situation to understand the physical importance for a system of particles. As we had already discussed that R is 1 upon m summation I equal to 1 to n m I r I. We are talking about motion of center of mass. If I rewrite this expression as mr equal to summation I equal to 1 to n mi r I have just rewrite this equation. So this r is summation vector, so it's better to write it in the form of vector forms. It's understood. Now I rewrite this equation as mr equal to m1 r1 plus m2 r2 and so on m and rn. If I differentiate this equation on both sides, then it will be m dr by dt is equal to m1 dr1 by dt plus m2 dr2 by dt and so on plus mn drn by dt. Where r1, r2 and r3 and so on rn are the position vector of particles whose masses are m1, m2, m3 and so on mn respectively. So this dr by dt, as we know, this is velocity. So mv, capital V is the velocity of center of mass, is equal to m1 dr1 by dt is v1. So this is velocity of particle 1 whose mass is m1. This is m v2. v2 is velocity of particle 2 whose mass is m2 and so on mn vn. So vn is velocity of nth particle whose position vector is rn and mass is mn. So in this way we have found out the linear momentum, and here m1, m2 and m3 and so on mn are considered as constant. They are not changing with time, so we kept them as constant. So this mv, this v, capital V gives the velocity of the center of mass. Now if I differentiate this equation number 4 again, then it will be m dv upon dt is m1 dv1 by dt plus m2 dv2 by dt and so on mn dvn by dt. So rate of change of velocity with time is acceleration. So m capital A, this capital A is the acceleration of the center of mass, equal to m1 a1 is acceleration of first particle whose velocity is v1 and mass is m1. Similarly m2 a2 and so on mn an is the acceleration of nth particle whose velocity is vn and mass is mn. Let me do question number 5. Now from Newton's law, second law, we know force is mass into acceleration. So for the first particle, mass is m1, acceleration is a1, so force is f1. Similarly, f2 is m2 a2 and so for nth particle, fn is mn en. So this ma is f1 plus f2 and so on fn. If I substitute all these values in equation number 5. So what is this F1, F2 and this is the force on first particle, second particle and nth particle respectively. So mass into acceleration of center of mass is equal to the sum of all the forces applied on all the particles which constitute a system. Thus, total mass of system of particles times the acceleration of its center of mass is equal to the vector sum of all the forces applied on all the particles, or the vector sum of the forces acting on the system of particles. So, if we talk about this F1 is the force on first particle. Similarly, F2 is force on second particle, Fn is force on nth particle. So this F1 force acting on first particle is not only external force. This is the force exerted by all the particles on first particle. That means F1 is sum of all the internal and external forces. According to Newton's third law, we know that these internal forces occur in equal and opposite pairs, and the sum of these internal forces is 0. So, it is better to rewrite this equation as Ma is equal to F external. Why F external? Because this F1, F2 and Fn, F1 includes both the internal and external force, but internal forces according to Newton's law, these internal forces occur in equal and opposite pairs, so they cancel each other. That means from F1 and F2 and so on, Fn, we have only the external forces, so I write F external as the sum of all the external forces applied on all the particles. This means this equation 7, equation 7 states that the center of mass of a system of particles moves as if all the mass of the system concentrated at the center of mass and all the external forces were applied at that point. That means to determine the motion of center of mass, we have no need about the information of internal forces. Only the knowledge of external force is helpful to find out the acceleration of the motion of the center of mass. So, due to this reason, in the future calculations, we will consider only external forces. That means to obtain this expression 7, we did not need to specify the nature of system of particles. The system may be a collection of particles in which they may be all kind of internal motions, or it may be a rigid body which has either pure rotational motion or translational motion or combination of rotational or translational motion. Whatever is the system of the motion of its individual particles, the center of mass moves according to this expression. That means equation number 7. You have already discussed about the equation of motion or the path of projectile. The path of projectile is usually parabolic, as we had discussed in our previous lectures, or you had already learned in your junior classes. Path is like this. This is an object. Now suppose in the middle explosion occurs. Suppose at this point explosion occurs and all the particles scatter in all the directions. So this explosion is due to the internal forces, not due to the external forces. Since there is no contribution in the motion of or the acceleration of the center of mass by external forces, by internal forces, only external forces works. So the behavior of or the path of the center of mass is again a parabola. So I represented it with the help of these dotted lines. Although the object is scattered now in all the direction due to explosion, that explosion is due to internal force. There is no contribution from the external forces. So internal forces, according to Newton's third law, they are in pair and act in opposite direction, so their contribution is 0. So that means we define the system by question number 7. So that means the behavior or the motion or the path of the center of mass is parabolic. There is no change in the path of center of mass. Let us recall the linear momentum of a particle is P equal to m into v. V is the velocity of particle, m is the mass of the particle, so P is the momentum of the particle. Now let us recall Newton's law of motion, F equal to dP upon dt. That is equation number 2. F is the force, P is the momentum, so rate of change of momentum is the force. Now suppose system is n particle system. Particle having mass m1, m2, m3 and so on, mn have their position vectors at r1, r2, r3 and so on, rn, and their velocities, so obviously v1, v2, v3 and so on, vn. So for the system of n particles, linear momentum P is the sum of vector P1 plus P2 plus P3 and so on, Pn. As we have already discussed that M R is M1 R1 plus M2 R2 and so on, M and Rn. And if we take time derivative on both sides, M dr upon dt is m1 dr1 by dt plus m2 dr2 upon dt. m1 and m2 and mn are constants, so they are not. So finally it is mv equal to m1 v1 plus m2 v2 and so on, m and vn. So that's why I write this equation as vector P equal to m1 p1 plus p2 plus p3 and pn. This is the vector sum of linear momentum of all the particles in the system. If I compare this expression 3 with our previous discussed equation vector A, then on the right hand side it is p1, p2, p3 and this is also p1, p2, p3 and so on. From these two equations, I can rewrite vector P equal to m into v. What is this m? Total mass of the system. What is this v? Capital V is the velocity of the center of mass. Thus, a total momentum of a system, a particle is equal to the product of the total mass of the system and the velocity of its center of mass. If we differentiate this, then it will be dt upon dt equal to m dv upon dt. T. So this dV upon dt is acceleration of center of mass mt. So as we are already derived from here, if we differentiate on both sides, it was m dv upon dt equal to m1 dv1 upon dt plus m2 dv2 upon dt and so on, mn dvn upon dt, and it will be ma acceleration of center of mass equal to m1 a1 acceleration of first particle, m2 a2 acceleration of second particle, and so on, mn en. So this is f1 plus f2 and so on fn. It was written as f external. So if we compare these two equations, then we will get dp upon dt is f external. Now suppose there is no external force act on the system. In that case, dp upon dt is 0. So from here, momentum T is constant. If momentum P is constant, then as we know P is m into v. If P is constant, then the velocity of center of mass is also constant. That means if the external force acting on the system is 0, then the total linear momentum of the system is constant. This is the law of conservation of linear momentum. Since this equation P equal to mv, as I write here, P equal to mv means that when total external force is 0, momentum is constant, that means center of mass moves with constant velocity. So this was all about the linear momentum of system of particles, and we have learned the physical meaning of center of mass. And so this is all about the linear momentum of system of particles, and we have found out that if there is no external force acting on the system of particles, then the momentum of the system is constant, and we can say that the center of mass moves with a constant velocity. Thank you for watching. Please subscribe the channel and share with your friends.